Yeah, g'day, Terry Gordon here from H&T Gordon Planes. This is part 2 in the video on scrutinising bevel angles and the clearance angles in planes. Now, the first part we looked at some cardboard cutouts which were taken, the shapes of the blades were taken from 2 sites by Steve Elliott and Brent Beach. Now, what it showed was that a 30-degree bevel compared to a 50-degree bevel is a lot sharper. And that was one of the first things that alerted us to a problem. Now, this is a very sharp 30-degree blade, right? Now, if I take a sharpening stone and put that at 50 degrees, and put a bevel on there, I'm taking away some of that sharp, usable edge of that 30-degree bevel. Now, if that's not quite clear, if I take that to the extreme, so keep coming up here with my bevel and put a 90-degree bevel on that blade, essentially that blade is blunt. So if you look back through history, that bevel has typically always been between 25 and 35 degrees. And also typically the recommendation would be for planing hardwoods you went closer to 35 because it had better edge retention. Now, beyond 35, I've never seen anything written about old timers using bevels at 50 degrees. This is a new thing. The second thing that we scrutinised with the cardboard cutouts was the clearance angle in planes. And it became quite evident from the videos, the cardboard cutout video, that the lower that clearance angle, the more likely that the lower wear bevel will cause problems for the plane user as the blade gets blunt. Now, per se, we don't have an issue with bevel down or bevel up planes. In actual fact, our original planes, where we optimise these tools for planing Australian hardwoods, cranky hardwoods, but we also made sure they could plane softer timbers as well, because one of my favourite timbers for making furniture is Australian red cedar. Not a particularly hard wood, but it is a difficult wood to plane. We use bevel down for planing most timbers, but where you get a timber that doesn't want to plane at all, we designed this plane so that we could reverse the blade to make the cutting edge at 90 degrees to the wood, which is scraping. So the combination of those two factors allowed us to say we have optimised this tool for planing nearly any timber, particularly hardwoods. A couple other features there is this thick parallel blade so that you can put it in the plane either way and not affect the adjustment of the wedge. And the same goes for this design. We can put the blade bevel down or bevel up depending on the task at hand. So we definitely don't have a problem with bevel up planes. What we're trying to show here is a problem that was presented to me by people that have low angle bevel up planes, sharpened at 50 degrees. When they were planing large flat hardwood surfaces, they found after a certain amount of time the plane would balk at the cut or skate across the surface. Now, that alerted us to check things out a bit more than we had. When we first heard of low angle bevel up planes sharpened with 50-degree bevels, we didn't think that was a good design simply because of that high blade bevel and the problems I just mentioned before. But we were blissfully unaware of how important that lower wear bevel, and with some research using Steve Elliott and Brent Beach's site, became quite clear why these planes with very low clearance angles have a problem planing Australian hardwoods. So we did some testings, and this video is just going to go into how we tested planes so you can assess yourself whether your bench plane is suitable for the way you do woodwork and with the woods that you use. Now, I want to make it really clear that this is not about assessing low angle bevel up block planes, right? This is about assessing bench planes which we have an expectation of a bench plane to be able to plane a large flat surface without balking at the cut. Now, if you take this low angle block plane, with the bevel sharpened at 30 degrees, this is a very nice plane for doing an arras or a nice small edge, or trimming the end grain on a narrow piece of wood. And we tend to use, we have a palm smoother ourselves, but if I was to use this plane, it would be for trimming certain parts of a cabinet once it's complete. Now, I've heard many times people say, oh, my little block plane stays sharp all the time, and that's because when you're doing a small edge where you're taking a narrow shaving, there's very little heat generated on the blade tip. So it's the heat that creates the wear in blades. Now, say you were planing lots of end grain, this plane would start to get blunt, or if you were planing lots of edge grain, if the lower wear bevel starts to interfere with the cut, if you push down hard, you'll very quickly overpower the wear bevel, and your plane will still cut nicely. Alright, but if you take this plane and take it out of its comfort zone by trying to take full width shavings planing a large flat surface, right, where you generate a lot of heat, this plane will soon become out of its comfort zone, and you will see the same effect as if you were using a bench plane. But in general use, for what it's designed for, this plane, that design is quite nice. What we're talking about today is bevel up or bench planes, where we found through experimenting that the wide blade on a large flat surface, the lower wear bevel became an issue, and also having to sharpen at 50 degrees also was an issue for planing cranky hardwoods. So the thing with planing a large flat surface, there's several variables involved with this. Now, the first one is your blade itself, so the quality of that steel, how nicely you've sharpened that blade, the how much clearance angle you've got in your plane, right? So the low angle 12 degrees. If we put this plane here, it's 30 degrees clearance. So there are variables. The other one that the other variable, which is important when you're doing a large flat surface, the tote handle is a different design to this one. So some planes are better as it gets away from your body. So that's another variable. The other variable is how hard is that timber, or how soft is that timber. These are all variables that come into assessing how good your bench plane is. Now, I'm not going to plane a whole host of surfaces this size. Number one, I don't have a softwood surface this big to plane. Also, if you're from the States, you use different timbers to what we do. So this part of the video is about showing you how we did some testing, so you can do your own testing on the timbers that you use to see whether the loss of clearance angle affects your work, and also whether putting a 50-degree bevel on your blade is beneficial to you. It's all about allowing you to assess that yourself. Okay, I'm now going to describe the simple test we did to ascertain how good the design, the low angle bevel up design was for planing Australian hardwoods, and whether we would make a plane like that. So when I'm going to plane a large flat surface, and this is particularly important if you're newer to woodwork, is just take a small piece of wood like this, what I call a test piece. Set your plane up properly, doesn't matter what type of plane it is. Set it up so that you're taking a 1 to 2 thou shaving, something like this, full width. Set your plane so that you can plane with the grain, get a shaving like that, turn the block of wood around and plane against the grain. If your plane is set up properly and the geometry of it is correct to plane an Aussie hardwood, then you will be able to plane with and against grain. I actually like this Tassie Blackwood. It's a real test, and if you can get that shaving both ways on this piece of wood, it is set to plane a piece of like a thick ash, or I think this is silver ash. There'll be no problems if I run across interlock grain or reversing grain. Once I've done that test, I'm very confident the plane will do that whole job. Now the test itself, as I said, I borrowed a low angle bevel up plane to do the test. I don't have it any longer, but the handle design and knob design is similar. So what we'll look at now is how I went about this test. So first of all, you know, if you're not sure how rough this bench top is, the bench top it was fairly flat anyway, but get a straight edge, check if there's any high spots you can work on then. But in essence, this bench top is 4 foot by 2.5 feet, or if I go over the surface once, that is around about 60 lineal feet. So if I went over it 10 times, on average for most blades, that would be about all you're going to get out of your blade. Your blade would be blunt, no matter whether it's bevel up, bevel down. If you're using a 50-degree bevel, that could be significantly reduced, but once again, it's up to you to test your own timber. So we started in this corner and just took consecutive passes all the way down to the end until we had the flat surface flat across that way. Now it's really important that you're taking consecutive cuts, because as you're taking consecutive cuts, you're generating heat at the tip of the blade, which creates wear. And it doesn't really matter what steel your blade's made out of, they all wear if you generate heat. Now you've got to keep going until, and when you're in close to your body, and probably your best test is not to, once you've got that flat, your best test will be when you're going this way, because that's the hardest wood to remove. It's a lot easier to take wood across the grain than it is to go with the grain. Now, when your plane is in close to your body, if your lower wear bevel starts to impinge on the clearance so that it's basically rubbing against the wood and creating more friction, when it's in close to your body, you will be able to overpower it. But when it gets down here, where you've got to reach away from your body, or more importantly, when you're out here and you've got to reach away from your body, right? That's when the plane will balk at the cut, and you won't have the power to press down hard enough like you do in here. Once you get out here, you don't have the power to push down as much. That's when you'll notice, if you're having a clearance angle problem, that's when you'll notice out here. Now, as soon as you notice it, and that might be after 2 minutes, it might be after 4 minutes, 6 minutes. It depends on how hard that timber is and how well you sharpen that blade. But it will happen. If you only got to look at Steve Elliott's website, where he describes the lower wear bevel coming in at some point. Usually in the test he did, it was at 100 lineal feet. And it just gets progressively worse depending on how hard your wood is. So when we first saw the plane balking at the cut, what I did was I brought it back to here where I could force the plane down. So I forced it down and took a shaving. Right, not this shaving, but I had a look at the shaving and I'm going, is that from a sharp plane? And the shaving actually looked really nice. So I'm going, that blade is still sharp, but the plane doesn't want to cut unless I force it down. And this is where we got into the research about lower wear bevels. So, and we kept planing for a while, but it got very, very difficult to hold the plane in the wood as you're planing along and moving the plane away from your body. All right. So you've got to plane long enough for that to become obvious, and then you do that little test where you force it down and assess your shaving. We have an expectation of all our bench planes that the lower wear bevel doesn't interfere with planing a large flat surface until the blade is almost blunt. As you saw from the carbide cutouts, all blades are affected by this. If you let your blade get blunt enough, that lower wear bevel, no matter how, even if you've got 30 degrees or 40 degrees of clearance, that lower wear bevel is eventually going to affect your ability of your plane to cut through the wood. But from our point of view, where we optimise our planes for Australian hardwoods, we do have an expectation that we can basically get to the blade to the point that it's blunt before that clearance angle has any large effect. And that's why we stick with 55 degree blade pitch or 60 degree blade pitch. This higher blade pitch is slightly better than for hardwoods than 55, but this has some advantage on the slightly softer timbers. So you can see that's quite a simple test to do to assess your plane. I can only encourage you, particularly if you're having problems, or you've had problems in the past, do that test under, make sure when you sharpen your blade you get it nice and sharp so you can shave your arm, or whatever test you have to ensure a blade sharp. Then you'll be able to say, yes, this is a good plane, or no, maybe I need to look at something else. To round off this video, I'd just like to talk a little bit about my experience as a woodworker. When I started woodworking, I had a number 4 Bailey pattern plane, and it wasn't really until I did a large flat surface where I was making a dining room table that I realised the limitations of this plane. And what I found was that the plane kept tearing because I joined several pieces of wood together. The grain direction wasn't all one way, so I'd get tear out, and also I'd have to force the cut. And when I got away from my buddy, trying to force a cut was quite difficult, I found. And in the end, I didn't understand all the factors involved, but in the end I went out and bought a belt sander, which I now regret, to finish that tabletop. Now, for a while there I gave away woodwork. I stopped doing it for a couple of years, and during that period I was up in Malaysia and I learned about this style of plane. Now, these planes were an eye-opener to me. When I came back to Australia, I started experimenting with making some of my own planes, and what I found was that a 60 degree blade pitch with a 30 degree bevel, I've never moved away from a 30 degree bevel, I found that I could plane the Australian red cedar that I wanted to. I didn't have the problems with the plane balking at the cut, and it also worked very well on some of our notoriously difficult hardwoods. At the same time, I realised through simple geometry with a thick parallel blade, if I reversed it and made it bevel up, I could actually use that plane as a cabinet scraper. So it had dual use, 60 degree blade pitch for planing most timbers, and for those really cantankerous ones I would just reverse the blade and make it into a cabinet scraper. This changed the way I did woodwork. In the end, I trusted this plane implicitly with anything that I was trying to do as far as planing Australian woods. When I had my number 4 Bailey pattern plane and I didn't trust it, what happened was when I would design furniture, I would disregard some timbers that I thought I couldn't plane. Now, when you actually trust a plane, and this is the plane that I trust, and I'm not suggesting it has to be the plane you trust, but once you do trust a plane, you will design your furniture based around good design, and you will optimise that design and not compromise it. Now, with any plane, no matter which one it is, there's time and effort required by you to learn how to use that plane, sharpen the blade, set it up properly. But here at H&T Gordon, our overriding principle is to make good quality planes and back it up with good education to keep woodworkers involved in woodwork. We go to wood shows, we do videos, we're available at our workshop and phone or email, so we're here to help you. I hope you found this video informative and educational. Thank you for watching.